In the United States alone, more than 1.3 billion concrete blocks are produced every year, enough to build millions of homes and commercial buildings. What's mind-blowing is how these blocks are made, not by hand, but in massive, high-tech factories that can churn out tens of thousands of blocks every single day. From piles of sand, gravel, cement, and water, to solid, uniform, rock-hard blocks that last for decades. The journey is one of precision engineering, chemistry, and raw industrial power. Today, we're taking you inside one of the largest concrete block factories in the world, where billions of blocks roll off the line in an incredible process you've probably never seen up close. But before we dive in, don't forget to hit subscribe, click the bell icon, and join us as we reveal the hidden stories behind the world's most essential materials. Concrete blocks start their journey with raw materials, the simplest ingredients with the most powerful results. Cement is essentially powdered rock that reacts with water to form an incredibly strong glue. Sand and gravel, aggregates that make up about 75% of the block's volume. These come from quarries, riverbeds, or recycled crushed concrete. Water, not much is needed, but just enough to trigger a chemical reaction called hydration. Which hardens the mixture into solid stone. Factories source these materials in bulk. Trucks and conveyor belts feed mountains of sand and gravel into giant silos. Cement arrives in powdered form by tanker trucks and is stored in sealed silos to keep it dry. Computerized batching systems ensure the recipe is exact down to the gram. It's incredible to think that something as simple as sand and rock can become the foundation of skyscrapers, highways, and bridges, just by following the precise formula. Once the ingredients are ready, the real magic begins. Inside massive mixers, cement, sand, gravel, and water are blended into a thick, gritty paste. Unlike liquid concrete used for pouring, this mix is stiff and dry, almost like damp earth. That's because block machines need it to hold its shape immediately. The mix is fed into automated block-making machines, huge steel presses that can produce multiple blocks in seconds. The dry mix drops into molds shaped like the blocks. Each mold might hold 4, 6, or even 12 blocks at once. High-frequency vibrations shake the mold, while hydraulic pistons press down, compacting the mix tightly. This ensures there are no air gaps and that the block is as dense. Unlike poured concrete, these blocks don't need to sit in the mold for thrace. A single machine can produce up to 10,000 blocks per hour. In the largest factories, multiple machines run side by side, churning out hundreds of thousands of blocks every day. It's almost like a bakery, but instead of bread, the ovens are curing chambers, and the dough is sand, cement, and rock. Freshly molded blocks are still weak. If you picked one up, it could crumble in your hands. To gain their strength, they need to cure. Curing is not just drying. It's a chemical reaction between cement and water called hydration. Factories accelerate this process by placing blocks inside huge curing chambers, essentially giant ovens the size of shipping containers. Inside, steam is injected at controlled temperature and humidity. This keeps the blocks moist while speeding up the chemical reaction. Within 12 to 18 hours, the blocks reach about 70 to 80% of their final strength. After a full 28 days, the hydration process completes, and the blocks achieve maximum durability. Factories don't wait a month, of course. The blocks are strong enough to ship the next day. But the curing continues silently even after they're delivered to a construction site. This curing process is what makes concrete blocks so reliable. They don't rot, they don't burn, and they can withstand earthquakes, hurricanes, and decades of wear. Think about it. Every single block you see in a wall has gone through this invisible chemical transformation. Rock formed not in nature, but in a factory. Not all blocks are the same. Some are hollow, some are solid, some are insulated, and some are decorative. Factories can change molds to create hundreds of designs, depending on the project. But no matter the type, every block must pass strict quality control tests. Samples are taken daily and crushed in giant hydraulic presses to measure their strength. Factories even recycle broken or rejected blocks by crushing them back into aggregate, ensuring almost zero waste. This level of precision means that when blocks leave the factory, builders can trust they'll stack perfectly and last for generations. Once cured and tested, blocks are stacked by robots into giant cubes, wrapped in plastic and loaded onto pallets. Forklifts carry them to trucks, ready for delivery. One truck can carry about 1,400 standard concrete blocks. A single large factory might ship out hundreds of truckloads per week, enough to build entire neighborhoods. The scale is staggering. Globally, humans produce over 10 billion concrete blocks every year. If you stacked them end to end, they could circle the Earth dozens of times. In the US, concrete blocks are especially popular in southern states like Florida, where hurricanes demand strong, wind-resistant construction. But they're also used in commercial buildings, schools, and factories everywhere. From one factory floor, the building blocks of entire cities roll out day after day. Every time you see a wall, a building, or even a garden fence, you're looking at the result of an incredible industrial process. A process repeated billions of times over, across the world. If you found this journey into the supergiant concrete block factory as fascinating as we did, don't forget to hit that like button, subscribe to our channel, and tap the bell icon so you never miss our deep dives into the hidden processes that shape our world. In a handful of modern recycling factories across the US, broken bottles, shattered windows, and piles of glass waste are getting a brand new life as colorful, durable tiles for homes, offices, and even luxury hotels. In today's video, we're going to take you inside one of these factories and show you exactly how trash becomes treasure. From the moment the glass arrives to the moment the finished tiles are packed and shipped, you'll see every step in the journey. And trust me, it's way more fascinating than you think. Before we jump in, if you love discovering how everyday things are made and how waste can be turned into something amazing, go ahead and hit that subscribe button and turn on the bell. We post fascinating behind-the-scenes stories every week, and you don't want to miss what's coming next. All right, let's head inside the factory. It all starts with mountains of glass waste. Every single day, trucks pull up to the factory loaded with recycling bins, giant bags from construction sites, and crates from municipal collection programs. This isn't just beer bottles and soda jars, it's everything. Old mirrors, cracked windshields, broken tabletops, even glass from demolished buildings. If it's glass, it can be recycled. At the gate, every load is weighed. The weight, the source, and the type of glass are recorded. That way, the factory can track exactly where each batch came from. It's like keeping a paper trail, but for glass. Here's the thing about glass waste, it's never just glass. You've got bottle caps, plastic labels, bits of ceramic, maybe even a stray fork or two. All of that has to go. So the first stop is the sorting line. Workers stand along fast-moving conveyor belts, pulling out big contaminants by hand, anything that could jam the machines or ruin the tiles. Next, the glass passes through high-tech separators. Air jets blow away lightweight trash like labels and paper. Magnets remove any metal, like jar lids or steel bottle rings. Screens and sifters shake out small stones or dirt. Then comes the washing stage. Imagine a giant industrial dishwasher. Jets of water blast away leftover liquids, sticky soda residue, and fine dust. After this bath, the glass sparkles. Some factories sort glass by color at this point: clear, green, amber, because it makes it easier to control the final tile color. Others keep it all mixed for a more speckled mosaic look. Now the clean glass heads to the crusher. This thing is a beast. Huge spinning hammers smash the glass into small chunks called cullet. If you've ever dropped a glass and seen it break into thousands of tiny pieces, this is the same idea, except controlled and consistent. The pieces are usually between the size of a pea and coarse sand. Why crush it? 2 reasons. 1, smaller pieces melt more evenly later in the kiln. 2, it's easier to mix with other ingredients when it's fine. The finer the glass, the smoother the final tile surface will be. For some designs, they even grind it to a powder so fine it feels like flour. Crushed glass alone can't hold the shape of a tile. It needs a glue to bind it together. This is where binders and additives come in. The cullet goes into massive mixing drums, along with clay or porcelain powder, gives the tile strength and structure. Pigments, or color. Want a bright cobalt blue kitchen backsplash? That's thanks to a pinch of mineral pigment. Fluxing agents. These lower the melting point of glass so the factory can save energy when firing. The recipe is like baking cookies. A little too much of one ingredient and the whole batch turns out wrong. Technicians carefully measure each component to make sure every tile looks and performs exactly the same. Once mixed, the material feels a bit like damp beach sand, gritty but moldable. Here's where the transformation starts to get exciting. The glass mixture is fed into tile presses, huge machines that slam down with tons of pressure, squeezing the mix into perfectly flat, square shapes. These presses can pump out hundreds of tiles per hour. For more artistic or decorative tiles, the mixture is poured into molds instead. Some designs even sprinkle in bigger chunks of colored glass at this stage, so when the tile is fired, you get gorgeous jewel-like specks inside. When they come out of the press or mold, the tiles look, well, kind of dull. They're just pale, chalky shapes. But that's about to change in the kiln. Freshly shaped tiles are still damp from the mixing process. If you put them straight into a hot kiln, they'd crack from the steam pressure. So they go into drying chambers, long, warm tunnels where hot air gently removes the moisture. This can take anywhere from a few hours to overnight, depending on the tile size. By the time they leave, the tiles are completely dry and ready for the big heat. The firing stage is where these lifeless chunks of glass and clay turn into something you'd actually want on your kitchen wall. The tiles are loaded into tunnel kilns, basically giant ovens the length of a city bus. Slowly, they move through zones that get hotter and hotter until the temperature reaches between 1,500 degrees and 2,200 degrees Fahrenheit, about 800 to 200 degrees Celsius. At these temperatures, the glass particles soften and fuse together into a solid mass. Pigments wake up, revealing their final, vibrant colors. Any larger decorative chunks melt just enough to bond with the rest, creating smooth, glassy patterns. The factory controls the firing time and temperature down to the minute. Go too hot, and you lose the color. Too cool, and the tile stays brittle. When the tiles leave the hot zone, they can't just be dumped into room air, they'd shatter from thermal shock. Instead, they pass through an annealing section, where the temperature drops slowly over several hours. This gradual cooling relieves internal stress, making the tiles much stronger. By the end of this stage, they're cool enough to handle, and they look completely different from when they went in. Smooth, colorful, and solid. Some tiles go straight to packaging, but many get extra treatment to make them even more beautiful or practical. Polishing for a glossy, mirror-like finish, texturing for slip-resistant surfaces, perfect for bathroom floors, glazing to add shine, depth, or patterns. The finishing line is where tiles really show their personality. It's also where quality inspectors check for chips, cracks, or color issues. Anything less than perfect gets recycled back into the process. Finally, the good tiles are stacked into cardboard boxes, cushioned to prevent damage, and labeled with size, color, and batch number. The boxes are loaded onto pallets, shrink-wrapped, and rolled onto trucks. Some will head to local home improvement stores, others to high-end designers or export markets. From here, they'll be installed in kitchens, hotel lobbies, swimming pools, anywhere a beautiful, durable tile is needed. It's proof that with the right technology and a little creativity, even broken trash can be turned into something beautiful and lasting. And that's the incredible journey of how broken glass gets a second life as beautiful, durable tiles. If you enjoyed this behind-the-scenes look and want to see more amazing transformations like this, make sure to subscribe and tap the bell icon so you never miss a new video. Thanks for watching, and I'll see you in the next one. Water, the most abundant natural resource on Earth. But beyond drinking, irrigation, or transportation, it holds power, immense power. In this episode, we take you inside the colossal world of hydroelectric energy, where millions of kilowatts are harvested each day from flowing water. From massive dams to precision turbines, from mountain reservoirs to electric grids powering cities, this is how hydroelectric power is made. Coming up, we'll dive deep into how gravity, water, and engineering come together to generate clean, renewable electricity at scale. Hydroelectric power, also known as hydropower, is the process of generating electricity using the energy of moving water. The principle is simple. Gravity pulls water downhill. That motion can turn turbines, just like wind spins a windmill. The key concept is potential energy. When water is stored at a high elevation, it has stored energy due to gravity. When it flows downward, this energy becomes kinetic, motion, which we can convert into electricity. The earliest versions of this idea powered water wheels in ancient civilizations. Today, it powers entire countries. At the heart of many hydroelectric systems is the dam. Built across a river, a dam creates a reservoir by holding back water and controlling its flow. One of the world's largest dams, the Three Gorges Dam in China, spans more than 2 kilometers across the Yangtze River. It can generate over 22,000 megawatts, enough to power millions of homes. The dam has multiple gates that control how much water is released. Behind it, the reservoir stores billions of gallons of water, like a giant battery waiting to be discharged. Engineers must carefully manage this water, especially during rainy seasons. Too much flow can flood communities downstream. Too little, and the turbines can't generate enough electricity. Once water is released, it travels down large pipes called penstocks. These pipes funnel water from the reservoir to the turbines below, often dropping hundreds of meters in elevation. The greater the height, the greater the pressure. This high-pressure water enters the powerhouse at incredible force, often exceeding 100 psi, pushing with massive energy. Some penstocks are as wide as subway tunnels and run several kilometers through mountainsides. They're made of reinforced steel to withstand the immense water pressure. At the bottom of the penstock lies the turbine, the workhorse of hydroelectricity. As water crashes into the turbine blades, it causes them to spin, just like a water wheel. These blades are part of a rotor, which is connected to a generator above. There are different types of turbines depending on water volume and head height. Francis turbines are the most common and highly efficient. Pelton turbines are used for high-head, low-flow systems. Kaplan turbines work well for low-head, high-flow rivers. Each turbine is massive. Some weigh over 100 tons and spin at hundreds of revolutions per minute. Every rotation turns mechanical energy into electrical energy through the generator.